Good evening, Algebra 2. This is your Quiz 22 review walkthrough. So on number 1, notice that we have a quadratic with 3 terms. I'm going to factor that to start. I need numbers that multiply to 6 that add to -5. Those are going to be -3 and -2. On the bottom, numbers that multiply to -15 that add to +2, 5, -3. Let's see, then x minus 3 divided by itself on the bottom will divide to 1. So I'm left with x minus 2 over x plus 5. Notice in the directions to state any restrictions on the variable. Your restrictions each of these need to be considered. So x plus 5 set to 0 means that x in this case would be -5, which means it can't be -5 in the original problem. X minus 3 was also in the denominator. So if x minus 3 is 0, then x is 3. So my answer is this, but x is not equal to -5 or 3. Next problem. Up top, I can take GCF of 6 out of both. So I can say that's a 6. 6 multiplies x plus 4. In the denominator, numbers that multiply to 12 that add to 7, 4 and 3. Remember, these problems are generally set up so that if you see it up top, you very well should see it underneath. So you can use that to help you factor. X plus 4s are going to cancel. So 6 over x plus 3. As far as restrictions, x plus 4. So x would be -4. X plus 3. X -3. So this is my answer, 6 over x. That's a plus sign again. 6 over x plus 3. But x could not equal -4 or -3. If you put the original problem in the graphing calculator and look at the table of values where x is -4 and -3, it will say undefined, as it should. Either of these will make the denominator 0. We cannot divide by 0. Number 3, I can take 3 out of both up top, so leaving x plus 6. Underneath, GCF of x this time, take x out of x squared, that leaves x. Take x out of 6x, that leaves 6. These will cancel, leaving 3 over x. So in this case, my restrictions, I'm not writing the whole word, x literally equals 0. That's the first factor. Also, x plus 6 to equal 0. So x is -6. So my answer is 3 over x, where x is not equal to 0 or -6. The next one, numbers that multiply to 49 that add to 14 are 7 and 7. So x plus 7 and x plus 7. Underneath, numbers that multiply to -49 that add to nothing. There is no x. These are both squares. The square root of x squared is x. The square root of 49 is 7. You need signs that multiply to make a minus, so 1 plus, 1 minus. These will cancel. X plus 7 over x minus 7. Don't get caught. Nothing else cancels here. These are a sum and a difference. You cannot reduce unless they are factors, meaning they're multiplied together. So don't get tempted and try to cross things out at this step. Doesn't work. Restrictions. X plus 7 is 0. So x is -7. X minus 7. Again, I'm looking at the denominator before I cancel anything. So x is 7. So this solution, but x is not equal to -7 or 7. I could have gone plus or minus there. Multiplying, if I can factor first, I'm going to. And I'm going to 6, nothing to do. Underneath, numbers that multiply to 20 that add to -9 are -4 and -5. Top right, I can take 5 out of both of these. So I can reduce those. Notice I have 6 times 5 over 15 underneath. That's 2. So 2, nothing else up top, x minus 4 underneath. Next one, 9 goes into 9 and 18. Underneath, multiply to -8, add to -2. That's +2 minus 4. Top right, numbers that multiply to -20 that add to 1 are +5 minus 4. Stop. X squared minus 25, those are both perfect squares. X and 5, a plus and a minus. Now I can look to reduce or cancel. So x plus 2's will cancel, x plus 5's will cancel, x minus 4's will cancel. So I'm left with 9 over x minus 5. My feline production assistants have joined the video. Oops. Division is simply multiplying by the reciprocal. So I'm not going to rewrite this entirely, but these two are going to flip. I can factor this. Numbers that multiply to 1 that add to -2 are -1s. 6x squared. Multiply, so 18x is going to go up top. I'm flipping again. Keep, change, flip that thing. Keep the first, change to multiply, flip the second. Numbers that multiply to -7 that add to 6 are, imagine there are 2 -1s there. It's -1 and +7. I can cancel x minus 1s. I've got 18 divided by 6. That's going to leave a 3. I've got x to the 1, x to the second underneath. So I'm going to be left with x to the 1. 2 minus 1 makes 1. So for all that, I have 3x minus 1 and x plus 7. On the next one, same thing. I'm going to change to multiply. I'm going to flip the second fraction. X squared minus 36 can go +6 minus 6. Underneath, multiply to 12, add to 8. That's 6 and 2. Oops, there you go. 6, 2. Multiply, numbers that multiply to -10 that add to -3, plus 2. There it is, underneath. Minus 5. Multiply to -5, add to -4. There's minus 5. And x plus 1. Now I look to reduce. X plus 6's will cancel. X minus 5's will cancel. X plus 2's will cancel. I'm left with x minus 6 over x plus 1. Monomials. If it's easier for you to put all these together, do that. I think I'm going to approach it that way. So I'm going to put the top together. going to put the bottom together. And remember, we're multiplying left to right. We are not cross-multiplying. So 12 times 4 is 48. A to the 3 times a to the 5. Remember, those exponents are adding, so a to the 8. This is a b to the 1. Remember, put the placeholder if you need it. 1 and 2 makes b to the 3rd. Underneath, 3 times 6 is 18. A to the 1 makes a to the 2. B to the 1, b to the 5 makes b to the 6. Reducing 48 over 18. Use your calculator if you want to. 6 goes into both of these, so this ends up being 8 over 3. A to the 8 over a to the 2, I'm subtracting. Answer goes where the bigger is, so on top is a to the 6. B to the 3rd over b to the 6. 6 minus 3, b to the 3rd underneath. Next one, similarly, I am going to rewrite this. 15x to the 5th, y to the 1 using that placeholder. Optional. X to the 1, y to the 4. Multiply and flip this. So 27x, y to the 7. There's a 1 there. 20x to the 9, y to the 3. These are big numbers. I can easily or more easily reduce them. So I'm not putting them together, but you could still if you wanted to use the calculator to reduce. I'm going to have 15 times 27, x to the 5, x to the 1 makes x to the 6, y to the 1, y to the 7 makes y to the 8. Underneath, 18 times 20 again. I'm choosing not to put those together. X to the 1, x to the 9 makes x to the 10. 4, 3, y to the 7. So let's see. As I look at this, I know that 15 and 20 are both divisible by 5, so I would have a 3 and a 4. 27 and 18 are both divisible by 9, so 3 and 2. And then I'll reduce. So up top, I've got 9. Underneath, I've got 8. Bigger x is underneath, so 10 minus 6 is 4. Bigger y is on top, 8 minus 7 is 1. Y, or if you write y to the 1, same thing. Now the last two, pull a graphing calculator. Looking at this, using the table of values, second graph, notice there's a vertical asymptote at 0, and I'm just trying to find some reasonable values from this table. So let's see, before I graph it, my horizontal asymptote is at y equals -3. I'm looking there. My vertical asymptote, x equals 0, I'm looking at the denominator. Let's see, as far as transformations go, this 4 up top would be a vertical stretch by 4, or a factor of 4. The -3 takes this graph and translates it down 3. Graphing this, I'm going to dash each of the asymptotes. Y is -3, 1, 2, 3. Points that I chose to use: -4, -4, -2, -5. I found these on the calculator. -1, -7. Then 1, 1, 2, -1, 4, -2. So now we plot dots. 1, 2, 3. Try to draw what looks like a somewhat smooth curve. This one clearly doesn't. Don't cross your asymptotes. So there and there. 1, 1. Make sure you remember where the origin is. It's right there. Don't get lost. Don't try to claim this is the origin. 1, 1, 2, -1, 3, 4, -2. again, graph with some sense of reasonableness, I guess, reasonability. There. Last one, 1 over x minus 2 plus 5 on my graphing calculator, pre-entered for my convenience. Looks like that. Again, second graph to find values. So let's see. Transformations, it's plus 5, so it's up 5. It's up 5. X minus 2 means this is going right 2. And you can see that from the graphing calculator image. The horizontal asymptote is at y equals 5. Again, you're looking right there. The vertical asymptote, denominator, basically solve it. X minus 2 is 0. X is 2. So I've got a vertical asymptote at 2. Got a horizontal at 5. 1, 2, 3. Points I used for this. I used some decimals just to give myself a little more to go on. Actually, I used 1. 1, 4. I used 1.5. 3. 3, 6. That's a 6. 4, 5.5. And 6, 5.25. I realize 5.25 is going to be a little bit small, but still. 0, 4.5. 1, 2, 3, 4.5. 1, 4. 1.5. 1, 2, 3. Again, try to make this look reasonable. Uh, 3, 6. This, remember, this is origin, so 1, 2, 3. 1, 2, 3, 4. 3, 6. 4, 5.5. Yeah, haha, 5.25, but it's, hey, that's not bad. And then again, yikes, try to do this on a tablet. It's harder than you think. There's my graph. Hey, that concludes this episode. Good luck on the quiz.